In this network topology, if we've got clients who are in a VLAN, let's say the client PC is in VLAN 10, and the PC3 is in VLAN 10, and PC2 and PC4 in VLAN 20, and there's a trunk that's going between those two switches. If you want to learn more about trunking, come see me on Sunday. And the challenge here is that devices in their own VLAN can talk to each other, and they're in the same broadcast domain. The client, let's say, mentioned Bob right here, and let me grab a color that we can see. So imagine Bob sitting at this PC, does a ping, and he does a ping to 10.16.0.30. So that behind the scenes, if he hasn't already learned the layer 2 address, Bob's computer for him is going to do ARP, Address Resolution Protocol. That's going to be a broadcast. That broadcast goes into the switch on VLAN 10. The switch says, oh my goodness, that's a broadcast. I need to forward this to every other port associated with VLAN 10, which in this topology also includes these trunks. So the broadcast is forwarded. It's also tagged at this point with VLAN 10. The receiving switch sees it, says, oh, this is a broadcast for VLAN 10, and then it forwards that broadcast to any ports, any access ports assigned in VLAN 10. And then PC3 can respond back, and life is good. I mean, traffic within the same network. What happens in Vegas stays in Vegas. Well, that's no problem. That works. However, if we want this client, like Bob at this computer, who's on the 10.16.0 network, if he wants to access anybody outside of his network, which also between friends means if he wants to access anybody outside of his VLAN, which is associated with his local network, he's going to need some help from a default gateway. So on Bob's computer, we configure a default gateway, and then basically Bob gets a packet. If he needs to send it to anybody who's not on the same local network, he says, oh, I need to forward this at layer 2 to my default gateway, at which point the default gateway would receive it, look at the destination IP address, and say, oh, I need to route this on behalf of Bob to the right destination. And that's what the Inter-VLAN routing is all about. It's layer 3 routing between the two. So if we want full connectivity in this topology right here, that's what we need to accomplish. And the video I'd like to share with you is pretty short. It's just a preview or an explanation of how we can get routing, Inter-VLAN routing, using not the traditional external router method, but using the multi-layer switch and how it works. And so I think, you know what, this is one of those discussions that I wish I'd had early on. I still remember my very first Cisco training or education on Cisco regarding multi-layer switching, and it took a while. It took like more than just a few minutes to kind of get it. And so my hope is that I can create this video, and as we go through it together, hopefully some light bulbs will go off. He's like, oh, I get it. And one of the big questions is, what is a VLAN versus an interface VLAN? And that mystery is also going to be solved by this video. So let me put the screen back on. Let me bring that video back up. And let's play it. Most corporate environments are going to do a convergence or a coming together for their layer 2 and layer 3 routing, meaning they'll have one physical box that can be a switch and also act as a router to route between VLANs. They call this device a multi-layer switch, and that's the focus of this video. And to appreciate this, let's go ahead and take a traditional layer 2 switch. So there's our beautiful switch. We'll call him switch. Switch number 1. And if we don't want to put all these ports into one network, we can chop this network up into smaller virtual networks. And we can do that by assigning ports to a specific VLAN. So perhaps these ports on the left we associate with VLAN 10. I'll color those red. There's VLAN 10. And on top of VLAN 10, we have the IP address of 10.16.0.0 with that 24-bit mask. And then for these ports over on the right, maybe we associate them as access ports in VLAN 20. So they're in VLAN 20 into this port. PC1 is now in VLAN 10. And if we take PC2 over here on the right, and we plug them into this port, PC2 is now in VLAN 20. And maybe each are a logical interface in each. Basically, this router with connectivity to both VLANs, maybe we give them the IP address of .1 here and .1 here. PC1 can use .1 as a default gateway. PC2 can use .1 as a default gateway. And now these two devices, PC1 and PC2, can send packets to each other on their respective networks and get responses because the router is providing layer 3 routing. Well, let's enter the new generation of the multi-layer switch. And here's how it works. We start off with a switch. Now, if this looks similar, this part is. And we can also partition these off. So all these ports on the left, we can associate those as access ports in VLAN 10. And the ones on the right here, we can associate those with VLAN 20. We still have our PCs that are attached, PC1 over here attached to the 10 VLAN, and PC2 attached over to the VLAN 20. And here's the magic for the routing function. Instead of having a physical external separate router, what they do with a multi-layer switch is they build in a logical router into this physical switch. So I'm going to draw this logical router with dots right here. Sort of like a phantom router. So logically, in firmware and software on this multi-layer switch, it has the ability to route between two different networks. It has layer 3 interfaces. But the challenge is, how do we identify those interfaces? On this router up here, the traditional router, it has interfaces like gig 1/0 and 1/1. What do we do down here for the interfaces that are representing and working with VLAN 10 and VLAN 20? Here it is. It's called an SVI. It's a switched virtual interface. It's just a logical interface. And the way you create them, yes, from thin air, on a multi-layer switch, the way you create those interfaces is say, I want to have a logical layer 3 interface for VLAN 10. You go to the configuration, say interface, space, VLAN, space 10. You press enter, and poof, you've got this logical layer 3 interface named interface VLAN 10. Then we would assign an IP address to it. We train our PCs to use that logical layer 3 IP address as their default gateway. And now PCs can route off of their local networks using the logical layer 3 interfaces, also sometimes called a switched virtual interface, that are now available on this multi-layer switch. So to complete this picture, we'd have interface VLAN 10. We could give it the IP address of 10.16.0.1 on that logical interface. We could create interface VLAN 20 for this VLAN and give it the IP address of 10.16.2.1. Then we'd have routing between those two VLANs, courtesy of the logical layer 3 routing capability in these switched virtual interfaces called interface VLAN 10 and interface VLAN 20. So that's how it works. And I thought to myself, wouldn't it be cool if we had a lab where we could actually go in and check out these logical layer 3 interfaces on these multi-layer switches? And the answer is we can. Let me share with you the topology, then we'll go to the interface. So if you're currently logged on to the CVT Nuggets website, you can click the link for the virtual lab. And what we're going to do is we're going to take a look just at Core 1. And Core 1 is an example of a multi-layer switch. So it acts as a switch at layer 2. It's got its trunks. It does Ethernet layer 2 forwarding, but it also has SVIs, switched virtual interfaces, interface VLAN 10, which supports this VLAN, and its IP address is 10.16.0.1 with a 24-bit mask. It also has interface VLAN 20, which supports this VLAN, and its IP address is 10.16.2.1 with a 24-bit mask. So these are the two names for these two interfaces, these layer 3 interfaces, interface VLAN 10, interface VLAN 20. So if you're logged on to the CVT Nuggets website, click on the link for the virtual lab. We'll open a tab for Core 1, and I'd like to do a couple show commands that verify that Core 1 has traditional layer 2 functionality and VLAN support, as well as its logical layer 3 interfaces, so it can provide routing services as well. So when this lab comes up, we've got some tabs for the access layer switch, the core switches, and also the router. Let's click on Core 1 as an example of the multi-layer switch, and let's do a few show commands. Let's do a show VLAN brief, see what VLANs are out there, and their port assignments, fantastic. If we want to see the trunks, we would use the command show interfaces trunk. You can shortcut that if you'd like. And this shows the trunks that are actively forwarding and which VLANs they're supporting. And so those are the traditional layer 2 things. We can also do a show MAC address table to take a look at the layer 2 addresses that this switch has dynamically learned. Those are all layer 2 functions. Now, as we kick it up a notch, if we do a show IP interface brief and we hit the spacebar a couple times, check this out. These interfaces right here, these are all layer 3 interfaces. They are the logical layer 3 interfaces, also called SVIs, switched virtual interfaces. Think of these interfaces, these VLAN interfaces, just like a traditional gigabit interface on a traditional router. You bring it up, you set the IP address, you set the mask, and then this device using that interface can provide layer 3 routing services. In fact, if we took it one step further and did a show IP route, check this out. This is going to show us the routing table on this multi-layer switch. And there is a lot of great stuff that is coming where we will further address things like static routing with IPv4 and static routing with IPv6 and dynamic routing with something called OSPF, Open Shortest Path First. All those skills and tasks and videos are coming up with labs to support them. But for this video, I wanted to share with you the concept or idea of a multi-layer switch to make sure that we're clear on what it is. It is a device, a box, that can do layer 2 forwarding based on frames. It can do trunking, all the traditional layer 2 stuff, but it also has the ability to do routing at layer 3. And to get into those VLANs, to have a hook, an interface in those VLANs, it uses a logical interface called interface VLAN followed by the actual VLAN number. And that's how it works. So thanks for joining me in this video, and I'll see you in the very next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing. All right, so there you have it. I also, while I was watching that, I enjoy watching the content too. I was like, okay, just like what we do at CBT Nuggets, we create the content, then we have a peer review. We get another person at CBT, another trainer to review our content with us and give us input. And I'm always nervous about, oh no, did I spell that correctly? So I really enjoy making the videos. Also, I wanted to explain my look today. This is the look of a man who has been sick for a few days. Last Wednesday, when we did the Wednesday afternoon live stream, I wasn't feeling good. In fact, I went back and listened to it. I thought, oh my gosh. And then I've been sick. So I did CCNA Sunday, rallied for that. But today, I didn't even shower. Here's my bad hair day in all of its glory. That's what it looks like with no shower and hair and a hat. Anyway, I love this time that we have together. I think it's really important to cover these topics and answer questions. Also, I discovered this, that sometimes if I hear something once and I think I've got it, like the concept of interface VLAN and giving an IP address, I find that if I can take that same concept and teach it to somebody else or share it with somebody else and explain it, that helps me understand it even that much better. I would encourage you to do the same technique. So whenever we're covering or addressing something or learning something new, find somebody, a friend or a loved one or anybody who'll listen to you, your dog, your cat, and explain it to them. And that'll help identify like, oh, how does that work? I need to revisit that. So it'll give you a chance to revisit that and make sure you've got it down pat. So in the light of reinforcing material, we have a few minutes. I would like to do this if you're up for it. I would like to take this topology, which is different than what the topology was in the video. And I would like to implement Inter-VLAN routing live on this topology. So let's imagine that we had these networks all set up. Let me bring up my drawing tool here. Let's imagine we had all these clients that were connected. My question for you is, before we configure Inter-VLAN routing for all these devices, so we have the 192.168.1 network out here with this server at .100. That's in VLAN 777. So this is an access port in VLAN 777. What are the chances in a production environment that they don't have their topology correct? The chances are strong. The force is strong with this one. I remember I did a Yucca Mountain. Anyway, I did a project for the government many years ago, and they had on this wall a map of their entire network. And I was teaching. I forget even what I was teaching at that time to them, but I was teaching something. And then on a break, I said, "Wow, look at this map of the whole topology and everything else." And I started to do. I asked them, "Is it okay if I, do a couple trace routes through the network?" It was made like 5 years ago, and it was mostly wrong, mostly not correct. So what's the message? So Keith, what's the message from that? The message is, whenever we're supposed to configure a network, it could be ours or a consultant coming in or a network that we put together ourselves from scratch, it's important to verify some of the basics on that device before we make changes. Because if we do some verification commands like that shouldn't be there and that shouldn't be there, we might be on the wrong device. The CLI, when you're remote connecting to dozens or hundreds of devices, it's easy to be on the wrong one. Like, oh, I was going to jump over to R2 and do a show command. And then in your mind, you go back to R1 and then you start doing a configuration change, but you're really doing it at R2. So it's always a good idea to do a quick verification. So in this topology, let's do this. This will only take a few moments. Let's verify that port 01 and 02 are on ports VLAN 10 and 20 respectively, and that PC3 and PC4 are in VLANs 10 and 20 respectively based on these ports. And also to help with this, I'd also jot it down. If I was in a production environment, I'd make sure I either had the screen available or documentation I could look down and make sure I'm on the right device. And if we want to configure inter-VLAN routing, if this switch here, switch number 3, is a multi-layer switch, we could just create 3 interface VLAN interfaces. Interface VLAN 10, interface VLAN 20, and interface VLAN 777. We'd want to make sure they're up, 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 and then we'd also assign the IP addresses. Now, the IP addresses for VLAN 10 should be what the network is expecting to use as a default gateway. So in this topology, every device is expecting to use .1 on their local network as their default gateway. So if that's the case, for interface VLAN 10 on switch 3, we would go ahead and do IP address, and not IP address, and then we'd put in the address of 10.16.0.1 with a 24-bit mask. Now you may know, or you may not know, that you can't do a /24 like /24. Most iOS is still required to do dotted decimal. I'm just putting that there to represent a 24-bit mask. And then for interface VLAN 20, we could create that logical layer 3 address to support VLAN 20 devices, IP address 172.16.0.1 with a 24-bit mask. And then for VLAN 777, IP address 192.168.1. And I don't know what the default gateway is going to be on that network, but I'm assuming it's .1. I don't remember. We'll take a look and see if that works. But if we have this configured, if we have these 3 layer 3 interfaces, and it's all configured correctly, and our clients are all configured to use those IP addresses as their default gateway, that should provide full internet connectivity between any and all of those devices. So that's the game plan. And I think it was Abraham Lincoln or somebody like that who said if we have like 7 hours to cut down a tree, you might want to spend a big chunk of that time sharpening the axe. And that is very true with networks, to plan out, think about what we're going to configure, then do it. Also make sure that in a production environment, we're going through change control. We're not just making nilly-willy changes, but we're getting a change authorization. We have a backup plan and all the rest, just to keep your job long-term. All right, so let me clear off that screen and let's go to, if I can find it, and I think I can, let me find that lab. Boom, and let me bring up my broadcaster software to make sure we can see it. I'm going to line this up just perfectly. So this is the admin PC that has terminal connections to each of the consoles of each of the devices. All right, so just as a test, PC3, which is in, I need to take a look at my topology. So PC3, which is in VLAN 10, at the address of 10.16.0.30 should be able to ping 10.16.0.10, the client PC, because they're in the same VLAN, and that's assuming we have these trunks that are currently working. All right, so let's test that. Let's just on switch 2, let's do a show interface trunk just to make sure we have the trunks. All right, so we have some trunks. VLAN 10 is allowed on all of them. That's great. And if we do a show VLAN brief, we can also verify that that port that PC3 is connected to, which is 1/0, that it really is assigned to VLAN 10. So these are some of the basics we'd want to do just to verify that the infrastructure that we think is in place. So if we go to PC3, and this is where Keith Barker holds his breath, ping 10.16.0.10, which is the IP address of the PC over on switch 1, also in VLAN 10, and hey, all right. So I'm glad that worked, and I'm glad it continues to work. But what we should not be able to do is no device on the network should be able to reach or access any device outside of its local network because we don't have routing set up. So let's make a road trip over to switch 3, which is a multi-layer switch. We'll first take a look to see what switched virtual interfaces it has, if any, and then we'll create them, bring them up, assign them IP addresses, and then test to verify we have inter-VLAN connectivity by doing a test from one or more PCs. So we'll go to switch 3, and here on switch 3, let's just do a quick show interface trunk. The reason I'm doing this is because if this switch 3 is not trunking, it's not going to be a good default gateway for any of those clients hanging up off of switch 1 or switch 2. So it looks like all the VLANs are forwarded and trunked, and that is great news from switch 3's perspective. Next, let's take a look at what layer 3 interfaces it has. To do that, we'll do a show IP interface brief, one of the Cisco engineers' favorite commands. You know what? I was expecting at least like a VLAN 1 interface for management or something. So on this multi-layer switch, it has absolutely no VLAN interfaces, no layer 3 interfaces at all, which is abnormal. In a production environment, we're going to have at least one of those for management, for remote management. Because we're not going to the console port every time on a production switch. We're going to want to remotely connect to it, probably with SSH or with our network automation tools. But certainly, we need IP addresses on a multi-layer switch if we want to remotely connect to it. Okay, so it has none. Let's solve it. And we're going to solve it by creating 3 interfaces, one for each of our VLANs. So we'll go into configuration mode, and we'll do interface VLAN 10 first. And you want to see something? Check this out. Do show. I digress. I'm going to stay focused. So interface VLAN 10, and then now that interface is created, I see that the state is saying down. So let's go ahead and bring it up with a no shutdown. All right. Survey says. There we go. Okay. So the interface is up. Now we need an IP address associated with that 10.16.0 network. And because all the clients already have been given IP addresses either statically configured or they learned it via DHCP, they're all trying to use 10.16.0.1 as their default gateway. That's the IP address we want to give to switch 3 on this switch virtual interface for VLAN 10. So we'll use the IP address command in 10.16.0.1 with a 24-bit mask. And bada bing, I don't know why I just got out. It's like, well, my work is done here. I have 2 more interfaces to configure, but I was like, oh, I'm so happy. I was just going to get out. So we have one interface, and it's also important to check our work. So hold on, Keith. Don't get going too fast. So let's do a check. Let's do a show IP interface brief. And there we go. So VLAN 10 has the IP address of 10.16.0.1. Let's go back into configuration mode, and let's take care of the other 2 as well. Interface VLAN 20. And in interface VLAN, for interface VLAN 20, we'll do IP address 172.16.0.1, not 160. Oh my gosh, I just washed my hands. I can't do a thing with them. 172.16.0.1 with a 24-bit mask, and we'll bring it up too. All right, and then while we're here, we'll also create the 3rd interface, interface VLAN 777, IP address 192.168.1.1. I'm hoping we'll verify that is correct in a little bit. And a no shutdown. Oh, unless I already did that. No, I didn't. Okay, so we'll do a show IP interface brief. Pipe exclude UNA. There we go. So what that is right there, that's just a pipe symbol. It says, hey, let's filter the output and control it. And this exe is a shortcut for exclude. So it said, please exclude any rows of output, any lines that have UNA in them. And that would represent all the interfaces that are unassigned IP addresses because I'm doing the show IP interface brief command. All right. So that looks good. VLAN 10, VLAN 20, VLAN 777. We now have, count them, 3. We have 3 switched virtual interfaces. And so switch 3, because it's directly connected to all 3 networks, if somebody forwards a frame to it for a different network, it should be able to, assuming IP routing is enabled. Let's check that too. It usually is by default on a multi-layer switch. Show IP routing. Oh, that's, the verbal to text mode doesn't work. Show IP. Oh yeah, that's exactly what I meant to do. All right. So if I did a show IP route and it said nothing like this, it just had like default gateway not set or something like that, it could be because IP routing is not enabled. So you need to also make sure that IP routing is enabled. So on a Cisco router and on this multi-layer switch, because I didn't tweak it, it's enabled by default. It's good to go. It's directly connected to these 3 networks. So let's test this. and let's go back to PC3. I think it's important to test when we do a test before and test after, is to not test like, I'm going to test from here, make a change, then test from here, then make a change, then test from here. It's nice to keep it kind of consistent, to remove the variables. And that way, we know PC3 can ping PC1, the client PC. So because we had success there already, let's continue there and make sure that PC3 can ping the new default gateway, the switched virtual interface on VLAN 10. And to do that, we can just choose the ping 170, wrong address. Ping 10.16.0.1. What do you think? If you were a wagering person, what would you think? Yeah, all right, rocking. That is working. Also, we can see here in the output for this little virtual machine that its default gateway is 10.16.0.1, which we just pinged. So we should be able to ping anything. That's a big call. We should be able to ping anything. So let's take a look, not at that, let's take a look at this. And let's do a test. Let's try to ping from 10.16.0.30 from our PC3 over to the server at 192.168.1.100. And that's a good test. So that'd be a PC in VLAN 20 on the 10.16.0 network who's using its default gateway, which is switch 3, to forward a packet to 192.168.1.100, which is on VLAN 777. You know what I didn't verify on switch 2? I didn't verify that port 3/3 really is associated with VLAN 777. Before we try that ping, let's go verify that as well. You know what? Well, it's 6 in one, half a dozen in the other. We could try it. If it doesn't work, then we could go verify it. But since I already said let's verify it, let's go ahead and verify it. So let me bring back the right window. There it is. And so on switch 2, oh, there it is right there. Yep. Port gig 3/3 is assigned to 777 as an access port. That's great. All right. So back to PC3, and let's do a ping to 192.168.1.100. Oh yeah, okay. So here was my big concern there. I didn't know for sure whether or not that PC, that server at 192.168.1.100, if it also was using a default route pointing back to .1, which was the switched virtual interface address. Now, if that had not worked and we still wanted to test our reachability, what we could do is we could ping from PC3 to the switched virtual interface address of 192.168.1.1 just to verify reachability and path through the network, as opposed to just having a device fail. So now that that works, let's do one final test, and let's bring up the client PC here in the lab. And in this client PC, let's just go ahead and confirm a couple things. So let's bring up a command prompt. I just want to verify the IP address on this guy. So on a Windows computer, that'd be ipconfig. It's 10.16.0.10 for its address, great. And its default gateway is going to be 0.1, which is the switched virtual interface for VLAN 10 that we just set up. We also verified previously a ping between PC3 and this device. That was before we set up the routing. So let's bring up browser. Chrome is on the desktop. I'll grab that and make that a little bit bigger. And I've got a web server running on that 192.168.1.100 device. All right, that'll have to do. 192.168.1.100. Yeah, that looks good. All right, and we can also verify the trace of the path, the TRACERT here from Windows, -D, don't bother doing name resolution, 192.168.1.100, and that should show the first hop of 10.16.0.1, and then going to .100 as well. All right, well, that went pleasantly well. Let's review what we did. We added switched virtual interfaces on switch 3, one to support VLAN 10, another switched virtual interface to support VLAN 20, another interface to support VLAN 777. We assigned each of those switched virtual interfaces layer 3 address that was appropriate for those networks and the IP address that all the clients were using as a default gateway. And then we tested by testing from the client first to make sure they could ping their default gateway, which is great. And then we tested end-to-end connectivity between VLANs, which is our goal of inter-VLAN routing. All right, well, you know what? Sometimes sometimes it doesn't go as well as we hope, as far as like, oh, what's this and what's that. One of the gotchas that I often discover when working with switching is spanning tree. I mean, spanning tree is a wonderful thing. It's needed a lot, and that's why we use it. But sometimes we make a change and it doesn't work, and it's spanning tree, especially if we're using the older IEEE 802.1d standard. It takes a while to converge. And so you bring a port up, and it may take, blocking, listening, learning. You can go have a cup of coffee, come back, and it's not quite done yet. So there are some tips that we can use to help speed that up for testing. Port fast is one of them on the individual switch ports. We could also do a command called switch port host, which makes it an access port and turns on port fast. We can enable rapid spanning tree as opposed to just the default original flavor of IEEE 802.1d. And those are all ideas of helping. But here's the cool thing. As a person practices and they get more familiar, when something doesn't work, what we can do is we can say, wait, okay, let's think about the whole process. And the more practice you have, the more exposure you have to the content, to networks, you can say, oh, like earlier today, I was working with Jeremy Chara, and we're working on some lab stuff. And it is so cool because there was stuff that wasn't working, and he and I were like, yeah, well, we're like, check spanning tree. And it's like we were in sync as far as like how, what to check, how to check, when to check. And I thought, yeah, there's nothing I need to tell Jeremy, and vice versa. There was no secrets to how the network is operating and why it might not be functioning. We are both on that same train, and that just comes with experience. So I also wanted to point out that I'm really excited about some new assessment labs. In fact, they'll be dropping up 5 o'clock. I'll do some posts on social media, Twitter and Facebook and LinkedIn. And these are assessment labs. And so here's I think you'll love them. Because here's what we did. I created some assessment labs for layer 2 switching. That involves trunking and VLANs and spanning tree, all things layer 2 at the CCNA level. And also I created some for routing. Static routing for IPv4, IPv6, OSPF, single area at the CCNA level. And I threw in some zingers, like configure this, it looks really simple, go. And it's not meant to be tricky, but I thought to myself, if someone goes through our CCNA training at CBT Nuggets, and they've gone through the videos, they've enjoyed them, and they've done the hands-on practice when we asked them to do the hands-on practice, they're ready. Yeah, they're ready. Not just to say I understand the concept, but yeah, I can configure this. I can troubleshoot this. I can set this up. I can verify it. And so I'll share with you one scenario, and I won't give away the answer because I want somebody who's doing the assessment lab to really hit it. And the assessment lab involves OSPF, and by default, the path is the wrong path. And you're like, what? Why OSPF did you do this to me? Why? You're supposed to be great, link state. And it is great, and it is link state, but we have to know how it works. And that training is in the CCNA portion. There's 2 sections of videos in the new CCNA. One is called OSPF. It's like OSPF concepts. It also has labs in it. And then one's implementing and verifying OSPF. So those 2 together would prepare a student who's been through those to just crush it. Like, oh yeah, I remember this. I know why. I know what to do. It's great. And the first time we do something, it's tricky. It is. The first time we learn a new skill, it's like, I'm not sure. How do I do this? But we're going to, the more you practice, and that's what the virtual labs are there for too. The more you practice and follow it step by step, you'll get better and better with it. And that's the key. If I look back to where I was, 25 years ago with Cisco, I started in 1989. That was my first introduction to Cisco. And then I got my first CCIE in 2001 and another CCIE in 2003. I still remember those early days, like looking at the CLI, like, what do I do? Where do I start? And so what's cool about the videos that Jeremy and I and Chuck Keith created is that you can watch the video. We'll explain the concepts, why it's important, how it works, and then provide you some opportunity for hands-on labs so you can actually do it. And so whether you use Packet Tracer, which is great for CCNA, or you use the virtual labs, or you have your own gear, it doesn't matter to me. I would love you to, but it does matter that you practice. And so that's our encouragement, is to, what can we do to reduce the friction, between a learner coming into Cisco, wanting to get their skills, and then being able to practice. And so whatever method works best for you, do it. And the more you practice, the more comfortable you'll be. And maybe in 10 years or 5 years, you'll look back on that training at CBT Nuggets and think, yeah, I get what Keith was saying when I was working with Jeremy today. Like, we are both so comfortable with all these related commands because we've been building labs and we've been diving into it again for the last 3 or 4 months building the new CCNA. So in a few years, you can picture yourself saying, yeah, I remember when I was brand new to that, and I think about where I am now. Holy shnikers, it's amazing. And you never know when the call is going to come in for you to apply those skills, because you might, networks that are in place, they don't change a lot. Like, you're not going to reconfigure routing every week. You're not going to reconfigure switching every week. But when there's a problem, and then you're looking, okay, where is this problem on the network? How many people is it affecting? You can think through it, looking at the topology, saying, okay, I think the fault domain, the area where the problem is here. And then based on your knowledge of how layer 2 forwarding works and how layer 3 routing works and all the access controls that also get mixed in, how they work as you improve your skills, you're going to be able to much more quickly troubleshoot those problems when they come up and resolve them without making knee-jerk reactions that might negatively impact the network. So it's coming. So I look forward to that day in a few years, or maybe even less, that you look back and say, yeah, I remember when I didn't know anything about Cisco, and now I'm just like rocking and rolling. And also the commands you learn in Cisco, on Cisco gear, there's a lot of similarities with other platforms too. So if you start seeing a Juniper device or Palo Alto or other, you say, oh, that's the same kind of concept, similar CLI, and you can start. HP has a lot of similarities on a lot of other platforms as well. Okay, so today, let me bring back this slide real quick. And today we focused on Inter-VLAN routing using a MultiLayer Switch. We took a look at the video. We used a different topology and implemented and verified it live, which was a lot of fun. Next Sunday, the 12/22, we're going to do 802.1q trunking. I'm looking forward to that very much. 12/25 offline. Please enjoy that with your friends and families and loved ones. And then CCNA Sunday, 12/29, spanning tree protocol, which I happen to love. Oh, you know what? If you have a minute, it was pinned, but it's not anymore. I've got, if we took 100, I would say, entry-level CCNA candidates, people who studied and they learned and then they got the certifications, they have the skills. Out of 100 of those, if we presented them with a specific spanning tree question and we asked them, why is that? Most of them would get it wrong. Or if we asked them to guess which ports will be forwarding, which ports will be blocking, or which ports will be root ports and so forth, a lot of them would get it wrong. And so I wanted to take some time and have a presentation where I can chat with you about the basics of spanning tree, give you a nice overview of what it does, and then also some basic steps that never fail in being able to determine and control spanning tree in an environment, whether it's IEEE 802.1d or rapid spanning tree. These concepts apply to both. So that's why I wanted to add spanning tree to CCNA Sunday on 12/29. And then New Year's Day, OSPF network types. And if you can't make it for any one of those, I will periodically post on social media the listing of all the URLs. And if you have a friend who is like, hey, you know what, I might be interested in Cisco or getting involved, feel free to refer them to that list of URLs. And the ones for CCNA Sundays are going to be ogit.online/CCNA01 and ogit.online/CCNA02, all lowercase. And so that way, when these months of Sundays are over, which eventually they will be, and we have this nice, fun collection of a lot of content that just got right to it, it'll be it'll be easy to find them. I'll put it in a playlist too, probably. But it'll be easy to find them, go through them, and if you want to get a study buddy, that I have discovered is extremely helpful. People have told me that, like, I interview people all the time asking, okay, what's the secret, right? What's the secret for you being successful and getting into IT when maybe some people said you couldn't do it or you didn't have a lot of support? One of the answers was a family or a friend or someone who believed in them. And I got to tell you, I have seen I'm not going to say tens of thousands, but I have seen thousands of people that didn't have a huge support group that were able to get the training, get the books, do the hands-on practice, watch some videos, consistently make progress in the right direction, and their lives are different. I mean, we're talking about people that didn't have homes or didn't have a place to live, and now they're doing extremely well. I believe in you. I think with the internet and the training options we have now, that anyone can do this. I mean, if somebody has a disease, like a mental disease or disorder, that's handicapped in that way, that might be some challenge. They might have to work harder to do it. But I think for an average human who wants to get the CCNA as a starting point, it's great. And also CompTIA has A+ and Network Plus and Security Plus. And then, I also just identified that on Cisco's website, they're keeping CyberOps. So as far as one CCNA to rule them all after February 20th, 24th, 2020, and CCNA CyberOps. So CCNA, the new one, is going to be out there, and based on what they have on their website right now, the other CCNA is CCNA CyberOps and all that content. There's 2 courses that go to that for that certification. One is fundamentals and one is operations, and those are both available at CBT Nuggets. If you want to check those out, feel free to as well. So thank you. I am so grateful that you've joined me for this time today. I enjoy teaching. I love helping to make a difference wherever I can. I'm grateful. If you haven't already, click on subscribe, hit the alert bell so you can make sure you get alerts. The fact that so many people are helping other people in the channel is fantastic. So if you see a question or if you see a comment where you can help, please feel free to jump in and do it. I make an hour or 2 a week to carve out to go try to catch up with everything. But the more we grow and the more people in the community, the more opportunities we have to help. And if you're not sure about an answer, you can say, here's my best guess. And as I look through those, I'll be happy to chime in as well. All right. So I will see, hopefully I'll see a lot of people back on CCNA Sunday, where we'll take a look at 802.1q trunking on behalf of the channel and myself, and coming off of this several-day cold. Thank you. Thank you for your participation, and I'll see you in the very next video. Thanks, everybody.
Calling